Hello everyone, this is EE-212 online lecture 1, Bode phase plot. So as you remember from our start of chapter number 12, what we did that we studied simple poles and simple zeros of the form this one is plus 1 or 1 by is plus 1, okay, and pole are zeros at origin of this form, and in third what we did, we combined these poles and zeros, both simple poles and poles at origin and simple zeros and zero at origin and we form this type of transfer function, say s into s plus 1 and say s into s plus 3 into s plus 5, okay. And we learned how to plot these, how to plot this zero at origin, simple zeros, pole at origin, simple poles, okay. And what we learn that how we draw its amplitude plot, okay. And what was that plot called? Bode plot, okay. Then what we learned that if we have some quadratic transfer function of this form, omega n square by s square plus 2 zeta omega ns plus omega n square, okay. Then we combine all these simple zeros at origin and complex poles and complex zeros, and then we studied learn how to draw its amplitude plot, okay. Now we are in a position to draw phase plot, Bode phase plot, okay. So you know that any complex number of the form, say we have a complex number, say v is equal to x plus j y, okay. So we know that it will have some magnitude, some amplitude of this form, v equal to x square plus y square, okay. And we will have some phase as well of this form. This will be equal to tan inverse y by x, right? So we already now know that how we can draw its Bode plot of this amplitude. Now when we plot this angle, this is called Bode phase plot, okay. So we will start with the same way, 0 or pole at the origin. Just look at, let's say we have a transfer function of this form, say h of s equal to, say, just s, okay. So we know that, let's say s equal to j omega, so we can write this equation as h of j omega is equal to j omega, right? So you know what will be its amplitude, but we are only interested in space, okay. What will be its phase? Yes, of course you know that, okay. So its phase will be 90 degree, right? This will be 90 degree. Why? How we know that this will be 90 degree? You already know, but just want to remind you something. Just look at this equation, that you have a complex number and you needed to find out its phase. What you did, that you divide this imaginary part over this real part, okay. So here we have over real part 0 and imaginary part omega, okay. So what we did, that we divide tan inverse omega by 0. This is imaginary part over real part, so imaginary part over real part. This is nothing but this gives you infinity, and tan inverse of this infinity gives you what? 90 degree, right? So straight away when you see a simple 0, you say that its angle is 90 degree, okay. It will start at 90 degree and it will end at 90 degree, Okay. Now let's say we have a simple pole at origin. Okay, this is 0 at origin. Okay, so if we have pole at origin, so we will have h of s is equal to 1 by s, right? So if somebody asks you what will be its phase, so you can straight away say that its phase will be, phase of this thing will be minus 90 degree. Why? Because we know that angle of this s will be 90 degree, so 1 by s will be minus 90 degree, right? So I think you are familiar with this concept. So this is a phase angle for poles are zeros at origin. Okay, this is polar zeros at origin. So this is easy, right? You don't need to do anything. If you have this transfer function and you need to draw its phase plot, you just need this omega. Okay, so if this is a 0, you just need one line plus 90 degree, and it is independent of omega, right? You increase omega, this angle will start from 90 degree until infinity, it will be 90 degree. Okay, and if you start with simple pole at origin, this will be minus 90 degree start, and it will end also at minus 90 degree. Okay, so this is a simple 0 simple pole, sorry, 0 at origin and the pole at origin. Okay, I think it's easy for all of you to understand, right? So we move little bit further, and let's see, we have now simple zeros, simple zeros are poles. Okay, you know what we mean by simple zeros and simple pole. Okay, so let's say we start with simple pole first. So you only draw simple pole and you will get idea how to plot zeros. Okay, the same way we draw simple zeros and we get idea how to plot simple poles. Okay, so let's say we have a transfer function of this form. H of s is equal to, say, s by 1 by s plus 1. Okay, we have this transfer function and we need to plot its phase. Okay, so first we can write it in j omega form. This will be nothing but 1 plus j omega. Okay, you need to understand that what is this one. This is nothing but this is your omega c equal to 1. This could be anything. Okay, we will see as we progress and solve the different example using simple poles. Okay, but just remember that omega c here is 1. Okay, now you have this thing and we need to find out phase of h of j omega. Okay, so what will be phase of this thing? This will be a minus tan inverse, okay, omega, right? I think you know that. What we did that we can write this equation as 1 by you understand this point, right? That where does this minus come from? Okay, you can find out its phase. This will be tan inverse of omega. Okay, and it is in denominator, so you can put minus sign and you will go to the numerator. Okay, so this is the angle minus tan inverse of omega. Okay, so now you just need to put different values of omega here and you will get phase of h of j omega. Say we write it this way. Okay, but you can put any values you want. Okay, but we are interested just in 3 values, as we were interested in 3 values of omega at which we find out the amplitude of this simple poles and simple zeros, and then a combination of all of these. Okay, so what we did, what we need to do is we can draw a table and then we can transform it to a Bode plot. Okay, so let's say we have omega over here and we have phase which is equal to minus tan inverse of omega. Okay, and we make a table of different, we put different values of omega here and we find out tan inverse of that omega. Okay, so let's say we put omega equal to 0.1 times of omega c. Okay, so 0.1 times of omega c is what? Omega c is 1, so this is equal to what? 0.1, right? This is 0.1. Okay, I'll write it here. This is nothing but 0.1. Okay, so now you just need to find out tan inverse of 0.1. Okay, the same way, let's say we increase a little bit. Remember that I'm putting lots of values here, but we are interested only 3 values of omega, okay, which we need for the plot, and the plot will be approximate. Okay, if you want to get the accurate plot, you will need to find out all these points. Okay, but initially just I'll show you what points will you need. Okay, now let's say now you just put 0.1 over here and find tan inverse of 0.1. okay, so if you find this value, this will be approximately equal to, just I say approximately because this will be around minus 5.75 or 5.76, but I'll say, let's say this is minus 6 degree. Okay, the angle will be in degree. Now if you put say omega equal to 0.1 times of omega c, 0.2 times of omega c, this will be 0.2. Why? Because omega c is 1. Okay, remember that this value will change when omega c is changed. Okay, but we will see in next example. Okay, so now this is 0.2 omega 0.2, so you just need to put 0.2 over here, find tan inverse, multiply by minus, you will get some result. This will be approximately equal to 11 points something, say 11.2, but we can take it minus 12 degree. Okay, now if you reach 0.5 of omega c, so this is 0.5 again, so this will be around say 22 times, so this will be 24 degree. Remember, this is approximate value. You have calculator, you can find out the exact values. Okay, but this is the overall methodology you need to follow. Okay, when say omega is exactly equal to omega c, omega equal to omega c is equal to 1, so you can say that tan inverse of 1 is what? 45 degree, and multiply by minus, this will gives you what? Minus 45 degree. Okay, now let's say omega equal to 10 times of omega c, so this will be 10. Okay, and you find out tan inverse of 10, so this is minus 74 degree. Okay, and then you can go on and you can put here say 100 omega c, this will be 100. Okay, this will be sorry, this is 84. Okay, minus 84 degree, this will be something 89.1 degree. Okay, 89 degree. Now you see what happening here, that where is our omega c? Omega c is here, right? This is our omega c. So when we go 1 by 10 times of omega c, we reach here. Okay, 0.1 is nothing but 1 by 10 of omega c. Omega c is 1, so 1 by 10. This is 0.1. So our angle is what? Minus 6 degree. Okay, and when we go 10 times up this omega c, so 10 times up omega c is this value, right? We reach this point. Okay, so this is minus 84 degree, right? As we reduce the value, say 1 by 100, we find out 1 by 100, this value goes on decreasing. Okay, this will be say 0.2. okay, I don't know the exact value, you can find out using your calculator. Okay, but if you find out 1 by 100, then 1 by 1000, you will see that this value goes on decreasing, so eventually it will reach 0 degree. Okay, so it means that your plot will start from 0. Okay, at 1 by 10 times up omega c, this will reach minus 6 degree. Okay, when omega equal to omega c, this will reach to minus 45 degree. Okay, and when omega reach to 10 times up omega c, this value, then your plot will be your angle will be minus 84 degree. So see here, the asymptotic value will be and ultimately it will reach to minus 90 degree, and it will bound by 90 degree. So we can say that minus 90 degree is its asymptote. Okay, so this is 6 degree up from asymptote, and this is 6 degree down from asymptote. Okay, so we can draw a conclusion that when we have this omega c and we find 1 by 10 omega c, okay, whatever this omega c is, okay, your angle at this value will be minus 6 degree. Okay, at omega c, this will be minus 45 degree. Okay, and 10 times up omega c, this angle will be minus 84 degree. Okay, so you can whenever you see a simple pole, you can draw these 3 points easily. Okay, just by looking into your transfer function. Okay, you can say that, okay, this is omega c, so we can say that at omega c our angle will be minus 45 degree. Okay, 1 by 10 times up omega c, this will be minus 6 degree, and 10 times up omega c, this will be minus 84 degree, right? So you can just look into transfer function, and you can draw these 3 points. Okay, so as before I told you that we are only interested to draw the approximate plot, so we will only need these 3 points. Okay, you can ignore the rest of the points. Okay, but if you want to get the accurate plot and equal to the way you draw it in MATLAB, so it will consider all these points. Okay, so the more points you enter into your graph, your plot, you will get the actual plot. Okay, the more your plot look like actual plot. Okay, but these values will give you just an approximation, and as before I told you that Bode is just an approximation. It tells you that whenever you vary, you change omega, okay, then you can see that how your amplitude will change and how your angle will change. Okay, so this is the way to look that I'm changing omega, okay, and how is our angle changing. So our angle is start from 0, then minus 6 degree, then minus 12 degree, then minus 24 degree, okay, then minus 45 degree, then minus 84 degree, and eventually when omega is equal to say 1000 times or 10,000 times up omega c, this will reach to minus 90 degree, right? So now it's a perfect time to draw Bode plot of our phase. Okay, so let's see how we can draw our phase plot. All right, so we just need to redraw these points. Okay, so let's say this is a logarithmic scale. Okay, so here let's say this is 0.1. okay, say here this is 1, say this is 10. Okay, this is omega. Okay, and this is our omega c. Okay, so this is every 10 times it increases this way, so it means there are 10 points over here, 10 points over here, but here the magnitude of one point will, because this is a logarithmic scale, the magnitude of one point will be 0.1. Here the magnitude of the one point will be 1, and here if you go further, say this is 100, then here it will again there will be 10 points, but each point magnitude will be 10. Okay, so each as we progress along omega axis, the points magnitude will goes on increasing. Okay, and over this axis we say that this is our phase angle. Phase angle of what? Our transfer function. Our transfer function was h of j omega. So this is our phase, right? So based on these 3 points which we draw here, we can say that at 0.1 our angle will be minus 6 degree. Okay, say here this is our minus 90 degree asymptote. Okay, so here at 0.1, when omega was equal to 1 by 10 times of omega c, our angle was minus 6 degree. Okay, so this is minus 6 degree. Now another point is minus 45 degree, and where was it occurring? It was at 1 when omega equal to exactly omega c. Okay, and then when omega equal to 10 times of omega c was 1 here, omega c in our case, in example, it was 1. Okay, we'll take different example to proceed. Okay, so when we reach 10 times of omega c, this will be say this point, and here this is minus 84 degree. So this point we can draw easily these points. Okay, so if you go beyond this point, this will approach to 0. Okay, so we can say that our plot will start from 0. Okay, it will touch this point. Okay, eventually this point, and when you goes on increasing the omega, your plot will goes towards this minus 90 degree, and it will touch this asymptote at infinity, somewhere infinity. Okay, so this is how your simple pole phase plot, Bode phase plot, will look like. Okay, you just need to draw this. Again, we are drawing it just approximation. Okay, so it will look like this. I think so you understand what we did here. Okay, so let's say we do little bit check with this plot. Okay, and to do further example with this. Okay, so we will take just simple poles. Okay, I told you that omega c for this example was 1. h of j omega is equal to 1 by j omega plus 1. Okay, so we plot its phase, and it's look like this. Okay, now let's say we change this omega c. Okay, so let's say h of j omega is now equal to 1 by j omega, say plus 10. Okay, now instead of omega c equal to 1, now your omega c is 10, right? So 10 occurs somewhere here. This is your omega c now. Okay, so let's say this is omega c1, this is omega c2, this was omega c, oh sorry, this is omega c1. Okay, this is omega c2. Okay, now our omega c is 10. Now what you need to do is draw its phase plot. Okay, so if you remember, I told you that whatever simple pole is given to you, you just need to find omega c, which we already find out that omega c is what? 10. Okay, so what we need to do is draw these points. Okay, we know that when we go 1 by 10 times of omega c, our angle will be minus 6 degree, right? And when we go 10 times of omega c, our angle will be minus 84 degree, right? So, and when omega equal to omega c, this will be minus 45 degree. Okay, so this is all omega values. Okay, now it means that 1 by 10 times this is omega. Okay, I'll just draw these points. Okay, and this is our phase. So 1 by 10 times of omega c is what? 1, and we need to find out tan inverse of omega c is now 10, right? So 1 by 10 times of this will gives you what? This is result of this value. This is 1. Okay, so what I told you, that when you go 1 by 10 times of omega c, you will get minus 6 degree, right? So you just need to shift this point to this point, right? So this is now minus 6 degree. When omega c is equal to minus 40, when omega equal to omega c, it means 10, right? So this will give you 10. Omega c is equal to omega. Okay, so this is 10. So you reach this point, and here this will be minus 45 degree. Okay, and if you reach 10 times of omega c, this will be minus 84 degree. Okay, so it will start from 0, it will reach minus 6 degree at 1 by 10 times of omega. Okay, and it will goes on like this. Okay, minus 45 at omega equal to omega c. Okay, and it will approach its asymptote when it reach to infinity. Okay, now if you change, say omega c 3 equal to say 100. Okay, now 100 is here. Okay, this is 100, this is omega c3. So based on our previous experience, we can say that, okay, here our angle will be minus 6 degree, here this will be minus 45 degree, and at say 1000 this will be minus 84 degree, right? Okay, so this will start with 0, this will reach minus 6 degree, then minus 45 degree at omega equal to omega c, and it will approach to minus 90 degree as we progress along with omega axis, right? So this is how you will plot different frequencies. Okay, so see what we did, that we shift this point from here to here. Okay, this point from here to here, and this point from here to here. Okay, so if you understand how to draw 1 by s plus 1, 1 by s plus 1, yeah, you understand this whole concept. The whole concept has nothing but just to remember these three frequencies. Okay, when omega c is equal to omega, and omega equal to 1 by 10 times of omega c, and omega equal to 10 times of omega c. Okay, that's how you draw your Bode plot. Okay, and remember that you can draw this table as well, but we already said that we generalize our form that omega c 1 by 10 times of omega c and 10 times of omega c, so we don't need to draw this table, but you can draw this table, and you can apply the previous formula, minus tan inverse. Okay, what is this imaginary part? This is omega by 10. So this is the omega values, this is omega, so you put 1 by 10 times of omega, so this will be 1, this will be 1 by 10, so again this is 0.1, and we already know, we already draw this table, so you don't need to draw this table again and again. Okay, so you just need to remember these points, that these three critical these three frequencies, that what will be omega equal to omega c angle, this will be minus 45 degree, what will be angle minus 1 by 10 times of omega c, this will be minus 6 degree, and what will be angle of 10 omega c, this will be minus 84 degrees. So you don't need to go into and draw this table again and again. Okay, you just need to remember these 3 points. I hope so you know how to draw this simple poles. Okay, now if I told you, if I ask a question that please draw Bode plot of this simple zeros, h of s is equal to s plus 1. Okay, write it down and take it as a home assignment. Say this is 1. The second transfer function is h of s is equal to s plus 10. This is your second transfer function, and take a third transfer function. Say h of s is equal to s plus 100. Say this is your third problem. Okay, say you can take another example as well. Say h of s is equal to s plus 5. Okay, this is a fourth example. You just you know how to draw 1 by s plus 1. Okay, this you already know that how to draw 1 by s plus 1. Okay, this is 1. Okay, and this is how you draw it. Okay, same way, just try to draw this s plus 1. I'll give you a hint that how we draw this table. Okay, you can draw this table, and then you draw this this plot. Okay, this plot. Okay, so let's say I'll solve this one and you will solve the rest 3. Okay, so what we have is h of j omega is equal to j omega plus 1. Right, so what will be angle up h of j omega? This will be nothing but tan inverse of omega. Remember, what is difference between this one and this one? This one. This is minus tan inverse of omega, and this is tan inverse of omega. So remember, this is negative and this is positive. Okay, so you can draw that table again. I know you can say you can simply draw it by just symmetrically shifting this plot over here. Okay, but just those of you who don't understand how to flip this, okay, just simply draw that table and find out those 3 frequencies and corresponding angle to those frequencies. Okay, so this is tan inverse of omega. Okay, so we can say that, say here we have omega and here we have phase, which is equal to tan inverse of omega. Okay, you draw this table. When omega is equal to 1 by 10 times of omega c, it means it is 0.1. Okay, the angle will be tan inverse of 0.1, which is minus 6 degree. Again, this is approximate. Okay, this is actually 5.76 or something. Okay, but we can say that this is approximately equal to minus 6 degree. Okay, then 1 by 5 times of omega c and so on, you can increase this value. Okay, say 0.2, this will be approximately equal to minus 12 degree. Okay, and at 0.5 this will be approximately equal to what? Minus 24 or 27 or 26 degree. Okay, say minus 26 degree. We are not interested in this frequency. Okay, when omega is equal to omega c is equal to 1, this is minus 45 degree. You just need to put these values over here and you will find out these phase angles. Okay, and this is plus. Okay, not minus. This is plus. Okay, because this is plus tan inverse, and you know where the minus sign came from in simple poles. Okay, now 10 times of omega c, this is 10. Okay, so tan inverse of 10, this will be minus 84 degree. Okay, and you can go on increasing these values, and you will see, sorry, this is plus 90, and you will see that at the end this will reach to minus 90 degree when you increase omega till infinity. Okay, now what values we are interested in? We are interested in this value. Okay, 1 by 10 times of this omega c value and 10 times of this value. Of course, we are interested in asymptote as well, but we looking into this, we can say that when omega equal to infinity, this angle will reach to what? Minus plus 90 degree, right? So our asymptotes will be plus 90 degree. Now this will be plus 90 degree. Say this is 0 angle. This is our asymptote. Okay, so here this is 1. Say here this is 0.1, and here this is 10. Okay, so at 0.1 our angle was how much? 6 degree. Yes, 6 degree. At 1 our angle will be minus plus 45 degree. I say minus 45 because I just did example, and that's what's coming from my mouth. Okay, so at 1 this will be 45 degree, and at 10 this was 84 degree. Okay, you just need to plot just draw this line, okay, and goes on it will goes on increasing. Okay, just look at this plot and this plot, this plot and this plot, this plot and this plot. So this is actually a replica. We just did flip this over this x-axis. Okay, so we get this value. Again, what will happen with the s plus 10, s plus 100, s plus 5, you already know. Okay, you just need to know what is omega c over here, what is omega c over here, what is omega c over here. Just move these points toward that omega c, okay, and you will find this value, and this value. So this is your home assignment. I hope so you understand how to draw these simple poles and simple zeros and pole at origin and zeros at origin. If there is any question and any part you don't understand, you are welcome to ask any question, and you know the means of asking your question. I am 24 hours available for you, so you can ask any question anytime. Okay, thank you.